Hello everyone, welcome back to the channel. So today's video is going to be an interesting one. In this video, we are going to pull back the curtains on one of the most mind-blowing technologies out there, that is large language models and LLM in short we say. We will try to understand how do these large language model actually work. So think about it, right, for a second. It really does feels like a magic, doesn't it, right? You ask a question and boom, you get a detailed, coherent answer. You ask for a poem, it just writes one. You ask for a summary for the detailed PDF, it will give you that. And that now the question comes, how is that even possible? How it is giving me those kind of answers to the questions which I'm asking to it or having it write down, right? And if you have worked on the AI Agent Studio within Oracle, like what you can see on the screen right here, you will probably notice something that when you ask a question, right, it calls an LLM behind the scene. If you see over here that I asked one question regarding variables, and here along with the agent call or the business object call, it is also adding the LLM calls. And these are the LLMs which are working behind the scene to be able to provide the answer to us. Now, if we go more deep dive onto these LLMs, like how these are working, we will understand one thing, right? Because they all are orchestrating calls to the language models at the end, right? If you look at the input section over here, it is calling the model like which is available in Oracle Cloud, that is GPT-5 mini model. And if you see parameters like P, temperature, and K, right? These are the ones are actually behind the LLM. And this is how LLM doing its work in real time, generating responses token by token using these parameters. You can see it is written like that, model parameters, right? And under that, these are the ones. But what actually happening inside that LLM call using these parameters, right? How does it go from your questions to a coherent answer? That's exactly what we are going to break down today, step by step in plain language. And at the end of this, I will also show you in a demo that how these all parameters, if it fluctuate, how the value will come up, right? So I will show you at the end. Now let's lead into that idea of a magic trick. Okay, so from the outside it looks impossible, right? Any great illusion, once you see how it's done, it all clicks into place. And here is the crazy part, that secret isn't some ridiculously complicated formula. Behind all these billions of data points and complex sounding technology, the core principle is actually surprisingly simple if you look at it. Okay, so let's go ahead. And the big secret is it's all about just word prediction. Seriously, that's it. That is the fundamental mechanism behind the LLMs. Okay. At their heart, these models are incredibly sophisticated guessing machines. Their one and only job, predict the most likely next word in a sentence. But wait, how does predicting the word or next word help answer complex question? Right? Because we do ask a lot of complex question with the chat models like ChatGPT, Claude. Well, that's the real genius. Predicting the words. It's about turning any task into a word prediction game. You do not ask the AI, is this sentence positive or negative, right? Or instead, we frame it sensitive analysis, like fill in the blanks type question, right? I watched this movie, the movie was, and fill in the blanks. And then what model will do? That model will read billions of movie reviews. And when it sees my sentence, it thinks, what is the most statistically likely word to come next? And answer can be uh, the movie was good, yeah, the movie was great, something like that, right? So it is not feeling anything, it's just predicting, right, what which word to come next. And now if we have understood this, if it is all about the prediction game, how does it get so good at it, right? Because it also solve complicated tasks. And to understand that, we have to see how these LLM learns. So the answer is pre-training. The key ingredient is a mind-boggling amount of text these LLMs being trained upon. The model is forced to read a huge chunk of the internet. Its only job is billions and billions of times to guess the next word. Now think about this, right? If every time it gets it right, it reinforces a connection. And somehow if it get wrongs, it needs to adjust. It's like the world's most intense flashcard session. And just to give you a sense of scale, we are not talking about the library's worth of books. We are talking about massive data set like the pile, web pages, books, scientific article, even computer code from Stack Overflow or GitHub. right? So it's a giant slice of all the text humanity has ever put online. All right. So model has done its homework, like that learning, the pre-learning phase has been done, and then we have understood. Now it's learned all these complex patterns, but now comes the really interesting part. How does it actually choose which word to say next? And this part, or the answer to that question, is for sampling. It's just not as simple as just picking the number one most likely word every time. That would be super boring and repetitive if you think about this, right? Each time I'm asking a question, it's giving me one word every time, right? So that will be more boring and repetitive. Instead, think of it like rolling a weighted die. So words with the highest probability are like the biggest sides of the die. So they are most likely to come up. But there is a small chance it could land on a less likely, more interesting word, right? There are chances for that. So here is the catch. If you just let it roll that die forever, sometime it is going to land on a really weird word that sends the whole response off the rails into the nonsense. And that's where, if you have chatted with these models, you will see that hallucination comes in. It gives me the wrong references or any data which you do not need at all. So to stop that from happening, we need some control, right? And the secret lies in sampling parameter. That is temperature, the top P, and the top K. These course setting directly influence how creative, focused, or diverse the model responses will be, and whether we are generating a code or writing a poem, summarizing the detailed PDFs, or powering intelligent agent in an automated workflow. So it's all about creativity versus the precision. Let's try to understand those three knobs which we started with initially when we looked at the Oracle Cloud LLM screen. So let's start with the first one. So knob number one is the temperature. So think of it as a risk or random tolerance. Turning temperature up or down does not remove any word choices. It just changes the odds. Turning it way down and the model become very conservative. It will always pick the most obvious high probability word. The output is focused but maybe a little boring because you are getting the same word every time you are asking question. If you crank the temperature way up, and suddenly those long, short, creative words become more likely. You get more diversity, more creativity. But now you have also increased the risk and randomness of the model, saying completely random or weird. And then comes the second parameter or sampling technique, that is top P. Another term for top P is Nucleus sampling, and it works very differently from the temperature. Okay, so it's a filter basically, and the model looks at all possible next words sorted from most likely to least likely and draws a line. It says we are only keeping the smallest group of words whose probability adds up to this threshold. If we set top P as zero point 0.5, that is 50%, it is good, that threshold, it becomes a group gone. That will not get considered at all. So a low top P gives a model a small, safe menu of words, very predictable, but a higher top P gives it a much bigger menu with unusual option, allowing for more surprise. And then comes the final one, that is top K. This one is much simpler, but more stricter. If top P draws a line based on probability, right? Top K draws a line based on count. So it asks like what are the top K most likely word? And if we are setting the, let's say, K value as 10, then model throws away every option except the top 10. It will only pick the top 10 words. Nothing else will get even considered. So think of like this for these three parameters. Temperature changes how risky or random the model feels. Top K decide how wider the menu is, but top K locks the. And once you understood these knobs, you will realize something very important. The model isn't just being creative or factual on its own, how much freedom it has at every single word which is being given to you. Now, at the end, we'll show you how exactly this works in practice. So I have built a live playground, okay, where I will be experimenting with these three parameters by switching and on a slightly scale and then showing you how that response get changed. So now I am on the live playground, which I have built, show you how we can experiment with these parameters, that is temperature, top K, and top P. So on this screen, you can see we've got temperature slider, top K slider, top P slider, the three knobs we just talked about. And let me show you what happens when we adjust them. So let's start with first with the temperature, and then I will show you the consolidated for all three. Okay. So this is the temperature now. So for now it is zero point 0.1. And if I say that question is the input context is the cat sat on the and these are the words which are there, which will come up next. Okay. So if I say generate, so for now it keeps on generating mat. Okay. And now if I start increasing the temperature, you can see the graph for each of those words, how those are coming up, right? So for now, if I am increasing the temperature, let's say 0.5, and if I now say generate, it comes floor, mat, 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 floor. So it keeps on changing, right? So it is picking all these three main words, right, at first. And we kept this top K and top P at max. And now if I increase it further, you will see more bar is getting raised up. And you can see at the top here, percentage also, which is showing over here, just 34%, 26% couch. So if I say generate now, for now it is saying mat, floor, floor, mat, couch, bed, bed, floor. So it keeps on changing rug, right? So it keeps on changing as I increase further. Now you can see if I make it 2, so more percentage got it. Earlier it was 36, now it becomes 24. If I now say generate, now it goes to sky, right? So the cat sat on the sky, so sky will be the next word. So that's how the temperature effect comes in. So at low values like 0.1, the model acts like a conservative report, picking the most obvious word that in our case was mat. Very focused, very repetitive. But now if I slide the temperature to becomes like a creative poet, choosing unusual word, more diverse. But sometimes it hallucinates because hallucination comes, for example, it is saying the next token is sky, and it may say the cat sat on the sky. How will cat sit on the sky, right? So that's how this hallucination, that's where the hallucination comes. Now moving on to the next thing, that is for now I will set temperature at the maximum and then move on to the next top 10. Currently you can see the top K is set to 10, that means 10 words. And on the screen you can see these are the 10 words. But now if I say reduce, right? So now you can see moon has been out. Now if I keep on decreasing this, right? This limits our token selection to only the K most probable option, right? If you're seeing this bar chart, right, it's showing us which words are available. When I adjust the slider, watch how words get filtered out, right? So if I say 4, now you can see only these 4 words will come into picture. These sky and other those things will not come into picture because we set a top case 4, that means 4 words. So if I say generate now, so it will only go between these two, net, couch, floor, and so only consider these top words and ignore everything else. That's how the top K works. And the final one is top P. Okay. So for now, if I say this one, right? But I have not changing the temperature, not changing the K. And let's say if I'm reducing this, so you can see 85%. So now here till here the 85% is comes in. Total is 100%, but till now the 185% is comes in. So if I more reduce it, so this 75% comes it over here. If I reduce it 50, only these three are coming. You can see these three are the one which are coming. Okay, so that's how it is coming at with this. So if we increase this, then more will be coming. If we decrease this, then we will just reducing the, we keep on reducing P, then it will be the 100% like this. So that's how it works. So if I say now generate, it will always be generating this. If I say now, then it will change. Okay. So that's how these, each of the probability that until when we reach the given probability, percentage probability, then it will cut off the rest. Okay. So now I will just try to see it now, right? So I will keep top K as 10 and then try reducing the temperature. You will see as I started reducing the temperature, this word becomes the main one, right? Keeping only the focused one. Now, if I say this increase, right? So this is how it becomes. But now I'm showing you between these two and keeping that total number of word at the maximum, that is 10 right now. I'm showing because these are the two ones which mainly affect the LLM models, top P and the temperature. So if I reduce it further, now you can see the effect. Mat becomes the one. If I increase, more will come. And now if I say more increase, the third word comes in. So that's how these two things correlate with each other. Now if I say 3 instead of 3, I will say 2. Now couch will no more. So that's how these three in correlation works. Okay, and that's how it works. Here I just shown you the infographics just to show you an example, like temperature. If we keep it low, then like a conservative robot picking the most obvious word, very focused, repetitive. High, like a creating poet, picking unusual words, more diverse but prone to hallucination. And top case, like example is like buffet with 100 dishes. And if you tell the waiter that only bring the top 3 most popular dishes, then waiter will ignore everything. He will bring whatever the top 3 are, right? He'll ignore everything because that's in terms of the token selection. And the final one is top P, that is Nucleus sampling. It is that you want 90% sure that you cover the good option. You keep picking the most likely. This is until the probability sum reaches the 90%. That's all about the LLM parameters, which we covered in the video. Thank you everyone for watching the video. See you in the next one.